This is the video demonstration of the simulation about the part with sorter control. The simulation is going to be running while I explain the problem and how the project is solved. Okay, so starting, we can use a ladder logic program based on the functional diagram approach. The system sorts parts into three bins based on their width, which is measured by two ultrasonic distances transducers, which are UX1 and UX2. The width is determined by subtracting the sum of two transducers readings from 16. Once the width is calculated, the systems eject the part into the appropriate bin. To eject the part into the bin, the corresponding eject cylinder control must be turned on for 1 second. The eject mechanisms are each controlled by a single acting air cylinder. The position which is a part to be ejected into a bin is creating a distance from the UX3 ultrasonic distance transducer. As soon as an eject cylinder controls is turned on, the UX3 reading is invalid because the part is being moved off the conveyor. The actual distance are measured by the ultrasonic transducers that are connected to analog input channels, and the device values are converted into units of inches and stored in internal memory locations as real numbers. Then ladder logic programs is divided into smaller steps and transitions that are linked together in a logical sequence. Step 1 repeats the initial connection of the systems, which triggers the system to start. Transition 1 con connect step 1 to step 2, which is the start of the conveyor. When the conveyor starts, the system waits for a part to be detected by the proximity sensors, represented by the transition 2. When a part is detected, the system moves to step 3, which involves using two sensors to calculate the width of the part. Depending on the width of the part, the system transition to one of the three paths, represented by the transition 3, 4, and 5. If the width of the parts is W1, the system moves to step 4, which is trigger timer 1 to start and eject 1 to open. If the width of the part is W2, the system moves to step 5, which triggers timer 1 to start and eject 2 to open. If the width of the part is not W1 or W2, the system moves to step 6, which triggers timer 1 to start and eject 3 to open. Then the system checks if the eject cylinder controls are on during the time the part is being ejected. If run is turned off during the time the piece is being ejected, the step should be completed before pausing. Also, when the run internal bit memory turns on, when the operation is paused, the station should resume the suspended step, and when it's paused, the conveyor should be turned on. Uh, The separate int reset initial bit memory is provided, which resets any initial states, so that when the run internal coil is turned on, the conveyor has already been cleared of any from prox to UX3. Finally, uh, through this video, you have been seeing how the simulation of this project works. Summarizing all of these, the ladder logic program controls the part width sorter, and this sorts parts based on their width, ejecting them into the appropriate bin. The program uses a functional diagram approach and breaks down the process into smaller steps and transitions. The system checks for the eject cylinder, controls, and has an int reset, that is the R reset, the internal bit memory to clear the conveyor of any items from the proxy, or as I name it in the tag, the prox, to the UX3. We have to go through a few steps to figure out the maximum and minimum values that will go into a scale block, as we can see it in the simulation when we were moving these values. And we use 4 and 30 as the maximum and minimum values for scaling, for the scaling blocks. Sorry. Then the ATC values range from uh, 5,530 to 2,764, and we calculated a line equation that gives us a negative value of 0.0012 because the minimum value is 30 and the maximum is 4. Using these equations, we got a total of 4 for the minimum values and 36.5 for the maximum value. We use another equation to calculate the width of the boxes, and finally, we use an additional block to add the center values and a subtraction block to subtract the results from 16.0 in our program. That will be our final and only explanation for these things.